Hello friends, in this tutorial video we want to use the Modbus TCP protocol with the factory I/O software. We will connect the EasyMens brand to the UAPL S-Series PLC. And also, using the Modbus RTU protocol over the RS485 network, we will connect the UAPL series PLC from the LS brand to this IC1 inverter. Let's see what settings we actually need to configure on the IC1 inverter for the RS485 network. In the Modbus RTU protocol, and also how should we program and configure our PLC. Let's continue with the video and do just that. Alright, step by step, we'll go through the procedures we need to follow for this task together. The first thing we want to do here is configure our relevant PLC. We want to set up the DNC PLC. We want to connect the ODU EAP to the factory I/O software via Modbus TCP and connect the PLC using the protocol. Modbus RTU was set up over the RS485 network and we want to connect it to this inverter, the LS model i3. Well, in order to use the Ethernet port or Modbus TCP on the LS PLC, when we open the XG5000 software, we select the PLC type as the U series. In the new PLC Ethernet section, when we click here, a window will open for us. Here, since my factory I/O software is acting as a client, meaning my command is supposed to be sent from factory I/O for the read and write operations, my PLC needs to be set as a server. So here in server mode, I selected the mode as server option. Here, there's an option for us called mode as setting. I set address 0 for the read array bit to MX2, and I set the address for the write array bit to MX0. I set address 0 for the word read array to MW50 and the word write array to MW100. So my address 0 for reading a single bit is MX2, and my address 0 for writing a single bit is MX0. That means if I want to get feedback from factory I/O, my address 0 is MX2. And if I want to send feedback to factory I/O, my address 0 is MX0. I confirm this. But I need to make some settings related to the IP address. Okay. The IP address for my factory I/O needs to have the same subnet ID as my PLC. I have correctly selected the PLC. So my PLC's IP is 192.168.15.100. The gateway I also selected today is 192.168.15.1. Is that okay? Alright, these are the settings related to Modbus TCP in the 25,000 software for LS PLC. Now I open the factory I/O software. Factory I/O is a software from Siemens where you can create all kinds of elements. You can create various projects in it and design your equipment using different methods. Alright, I click on the open option, and this one here in this section, it provides us with various projects, so we can choose any of the projects we want. We can use them here. I've selected a project, a conveyor that carries an object. But if you want to bring in the push buttons that are on the panel, or place the panel box itself from here in this section you select the operator option. You'll see that there are all kinds of push buttons, emergency stops, 2-position switches, potentiometers, even panel boxes and panel stands. Whatever you need, you can choose from here. Here I selected a panel stand. I brought in a type of box, a start push button and a stop push button. The start button is for running the conveyor and the stop button is for stopping the conveyor. Okay, but the other settings that we need to do in the factory I/O software, the most important settings are done in the driver section. In the driver section, here we specify which brand and which device we want to connect to. Since the factory I/O software doesn't have the LS brand here, we want to connect to the LS PLC via Modbus TCP IP client, so we select Modbus TCP IP client. In the configuration section, we set up the settings for this Modbus TCP IP client. Well, in the XG5000 software, we set the PLC's IP address to 192.168.15.100. Here, as you can see at the top, we need to provide the server details to the software. It says that the server you are going to connect to, you will read some information from it and write some information to it. What is its IP? Well, we need to enter the PLC Simon's IP here. The port is 502 and the IP is 192.168.15.100. Well, since we are acting as a client here, in the Read Digital section, we need to select the coil option. And in the Read Register section, select the Holding Register option, because we want to send some information by pressing the Start button. In the morning, send the data to the PLC Simon. Here the quantity is specified. It asks, how many inputs do you have? How many outputs do you have? How many input registers do you have? How many output registers do you have? Well, here I said I have 3 digital inputs. I have a start button, a stop button, and a sensor, the sensor that's at the end of the path on the common wire. I have a digital output. How many do you have? I say, I have 1 digital output, but I set it with an offset of 2. Why? If you paid attention, in my PLC here, in the Modbus settings, I set the address for the read area, the bit read area, to MX2, meaning I started from the second address. So in the factory I/O software, the digital out should also have an offset of 2, meaning my address should start from the second address. Well, I don't need the input register, but my output register also needs to start from the second address, and I only need 1. Alright, but these were the settings we made in the factory I/O section. Now my PLC is connected via a network cable using the Modbus TCP/IP protocol. It's connected to my laptop, which has the factory I/O software installed. Now if I've set up both of these correctly, when I click the connect option, you'll see that this green check mark appears here. This means that the factory I/O software is now connected to the LSPLC. So as you can see, it has also brought up the schematic for me here. I brought a start-stop button from here, and now I'll put it back. I have a start-stop push button on my coil 0. I have a stop button, a stop push button, and a sensor that was placed at the end of my conveyor. There's also one at the beginning of the conveyor, which activates the conveyor. It's my output contact. And my hold register sends my data to the PLC. Okay, so the factory I/O software is now connected to the LSPLC. Okay, now let's go back into the XG5000 software. Now, I want to use the LSPLC to connect to the inverter via Modbus RTU over the RS485 network. How do I connect to the inverter via RS485? What should I do? When you click on this sync section, the activation window will open for me. Channel 1 is my RS232 network and channel 2 is my RS485. I want to connect to the inverter via the RS485 network, so I'll do my settings on channel 2. I set the network to RS485, the baud rate to 9600 and the station number to 1. Then I go to channel 2 and set channel 2 to the Use P2P option. I select it and press OK. When I set it to use P2P, here, a page appears with several options for me. Alright, in the P2P channel, since I selected channel 2, I specify under which protocol I'm supposed to connect to this device. The RS485 network, under which protocol? I select Modbus RTU client because I'm going to use the Modbus RTU protocol over the RS485 network to send data to the LS inverter. So I select Modbus RTU and click OK in the P2P block. Now I choose my channel, which was channel 2, Modbus RTU client. I select the P2P function as write, right? Because I'm going to perform a write operation and send the frequency value. to the inverter, and I'll also send the start sub command over the network. For the inverter, I set the conditional flag to 100 milliseconds. My command type is continuous and the data type is, since the values I'm going to send to the inverter are of integer type, I set it to word. Now, for the data size, here I've set it to 2. You can also set it to 1 since you're only going to send a single value to the inverter. My station is set to 1 because my device, the inverter, needs to have the same station number as the PLC. So I chose 1 so that both are set to 1. Here, I'm saying that for the device with station number 1, I want to send its value, but here in its settings, it asks, where should I read from and to which address should I write? I tell it to read from MW5, which I wrote in my PLC program, and write it to address 4 of my inverter. Address 4 and address 5 in LS inverters are used for reading and writing the frequency value. But since here we're accessing address 475 via the network, we subtract 1 from the address value, so it's address 4, but for the stack register, we subtract 1 from 6. And we give it the value 5. We read from inverter address 7 and write to address 5. But the program I've written here is for the frequency value. I assign a frequency value, then move to out, and now to multiply it by 100, I've used a mul function. Store it in inverter address 5. Because in our settings, we've specified that here, from the inverter address, write it to inverter address 4, which is the frequency value. Alright, that's for the frequency value, but for their start and stop, okay. Over there in the factory I/O software, I had a start, a stop, and also a sensor. Now if I enter the driver here, you can see that my coil 0 is the start, address 0 is the start, address 1 is the stop, and address 2 is the sensor. In the software as well, we've specified that our MX0 here in the FENet section, in our Modbus map, the address related to the bit write area starts from MX0. That means my 0 address becomes my MX0. Here I'm assigning MX0. For my start, since my stop is normally closed, I select the normally closed contact, which becomes MX1 and MX2. My sensor is also my sensor, and it is normally D. It's in a closed state, and here we use the normally closed contact. So my MX0, which is supposed to read the value from there, becomes this. My start, my MX1 becomes stop, and MX2 becomes the value, which is the address related to the sensor, but I put all of it right here and set its address. MX2 is the same value that I entered here in the factory I/O software, which means address 0. I set it to start from MX2. Okay, I connected my output to MX2. Start is on MX0, MX1 is stop, my sensor is MX2 and MX2. And in the coil, MX2 is also set so they don't interfere with each other. If you select MX2 in your read area, select it. There's no problem. And even if you select it in the right area, they won't have any issues or interference with each other. Okay. But for start and stop, we've specified here that for starting and stopping, this inverter is supposed to get the values from the input. It should read from address 7 and send to address 5. So here I've set it so that if my MX2 is activated, meaning this contact is activated, it will write the value 2 into inverter 7. If my MX2 is closed, meaning it's deactivated, it will write the value 1 into inverter 7. So what does this mean? If you give the value 2 to address 3.05 of LS inverters, it means start in the forward direction. If you give the value 1, it means stop. And if you give the value 4, it means starting in the reverse direction. Here I only want one direction. So the value 2 is sent to the address of inverter 7, and according to this table, inverter 7 writes the value to address 3.3.0.5. So if you give the value 2 to address 3.3.0.5, it will start in the forward direction. If you give 0, the inverter will stop, and if you give 4, it will start in the reverse direction. Alright, that's my program. I connect to it. I load the programs into the PLC, click on write, click OK, and wait for the programs to be uploaded to the PLC. And I click OK. I run the PLC. Then I connect to it. The PLC is in stop mode, and we select the online monitor option. Alright, but the settings that need to be just slightly adjusted. Done in the software in the inverter itself. Alright, but let's go to the device, because if we want to set the frequency value on these iS7 inverters via the network and also perform start/stop via the network, we need to enter the DRV group. Press the mode key once to enter the parameter groups. In the DRV parameter group, I go to parameter DRV06, which is labeled common source. This means that your start/stop reference, the place where you control start/stop, should be set to DRVSF6 on port 485. So if we want the start/stop on our iS7 inverter to be controlled via the network, you need to set the parameter to DRVSF6, which is the same as CMD source on port 485. We select this option and press the prog key. Now, if we also want to set the frequency on our IC Bell brandless inverter via the network, that means if we want to set the values via the network, we need to set the parameter DRVSF7, which is frequency reference source, again to the sixth option. In other words, set it to INT485 and press the prog key. If we go back, you'll see that both our frequency setting is now coming from RS485, it shows the letter R, and our start/stop is also controlled via the network. So both our frequency reference and our start/stop reference are coming from the network. So using parameters DRVSF6 and DRVSF7, we were able to configure this for the inverter. That means we have to send the frequency value to the inverter via the network, and the start/stop command also comes from the network. But where are the network-related settings configured? Again, we press the mode button. We enter the parameter groups, and using the right key, we go to the communication parameter group. The parameter related to the station, which we also set in PeerSim. ComSF1, where in PeerSim we set our communication station to number 1, so here we also set it to 1. It asks, what is your protocol for RS485 communication? Here, we said we want to connect to the LS inverter via the Modbus RTU protocol, so we confirm it and set it to the first option, which is Modbus RTU. But our baud rate in the settings related to the PLC, in the software, what was it? It was set to 9600. So in the COM settings, we also set our baud rate to 9600, but our next parameter is the number of data bits and stop bits, which here is 8-1, and in our PLC we've also set it to 8-1. So we've done the network related settings in the COM parameter group. Alright, now I'm going to connect the PLC sim and run it. It's connected to the factory I/O software. PLC sim is in run mode in the factory I/O software. I click on connect. The connection between the factory I/O software and my PLC sim is established, so I'm going back. Alright, now I'm going to run the factory I/O software. As you can see, in this video, it's currently in stop mode. For example, let's say I set a value, a frequency of 50 Hertz, or maybe not. I'll set the inverter to 35 Hertz. You can see that the number 35 appeared on the inverter's monitor, meaning my frequency is now set to 35. Alright, you can see that the monitor displays 35. Now, if I press this start button, the inverter should start running in the forward direction and my conveyor should begin to move. I press the stop button. You can see that my conveyor has started running. If I press the stop button, the inverter, you can also see that the stop indicator light turned on and my conveyor stopped. If I press the button again, my conveyor started running again. And if I press stop, this inverter will stop and my conveyor will stop moving. I press start, and if it reaches this sensor, this inverter will stop and my conveyor will halt. Okay, it reached this sensor. Alright, I'll start it again one more time. This inverter starts up the electromotor and sets the conveyor in motion. If I press the stop button, if I press this button, but it sends the stop command and my conveyor stops. If I press the start button again, my conveyor starts moving, and if I press stop, the stop command is issued, causing the conveyor to come to a complete stop as expected. So in this video, we learned how to use the factory I/O software, how to connect an LS brand XGB PLC via Modbus TCP, and also how to connect the LS PLC to an LS iS7 inverter through an RS485 network using the Modbus RTU protocol, as well as what settings need to be configured on the inverter itself.